Hello, my name's Chris Love. I'm with the Information Lab and the Tableau Zen Master. Last week I did a talk about the way to create charts and how Tableau works, how to create quite advanced charts. And as I went through all the basic principles and things, one thing I didn't have time to do was talk through how to create a Coxcombe chart. Now I think this is a really good example that you can try and do yourself and learn about trigonometry, the way things work, how Tableau's building things, and also how to create one yourself and other kind of charts as well. So what I thought I'd do is record another video on how to do that. I'm going to use the same example. So I've got here the FAA wildlife strikes data. So that's aircraft striking different animals, be it on the ground or in the air. Most of them are birds, as you can imagine. What we've got is data on when those collisions happened. So I've created this group that just groups them up into morning and afternoon and evening, shows the hour of the collision, and also the number of strikes across here. Now, one thing I need to point out is I've had to play around with this data. For some reason, the midnight and noon records were put into one. So what I've done is just mucked about with that to make it look a bit better for the purposes of demonstration. So just bear in mind this isn't 100% accurate data. We don't really care about that, but there we go. I've done my due diligence. So let's start talking about how we start thinking radially in Tableau and how we start drawing circles. Now, I'm afraid I'm going to have to take you back to high school, back to SOHCAHTOA. This is the way I remember my trigonometry, so that I don't have to look up calculations all the time. What is SOHCAHTOA? Well, SOHCAHTOA helps me remember the calculations to work out the angles and the distances when I'm plotting the point of this point just here, finding the X and the Y. Then all I need to do is remember when I'm looking at that point with reference to this angle A, then I just need to know that this point is the opposite side and this side is the adjacent side. This one, the long side of the triangle, is the hypotenuse. So what SOHCAHTOA tells me, SOH tells me that sine equals opposite over hypotenuse, i.e. the sine of this angle is equal to the ratio of this angle divided by, this side divided by that side. The cosine is equal to the adjacent divided by the hypotenuse. So the adjacent divided by the hypotenuse. And the tangent is equal to the opposite over the adjacent. Opposite over adjacent. How do I use those to find the coordinates of this point? Well, it means that I simply multiply the hypotenuse. So we rearrange this equation here. Rather than sine equals opposite over hypotenuse, we multiply by the hypotenuse to get hypotenuse multiplied by the sine of the angle equals this distance here. Similarly, if we multiply the hypotenuse by the cosine of the angle, we'll get this distance, the y distance here. Now, one thing we need to remember when we're doing this is how to convert this angle into radians, which is what Tableau uses when it's calculating the sine and cosine. To do that, we just divide the angle by 360, because there's 360 degrees in a circle. That's the percentage of the way around the circle it is. And there's this 2 pi radians in a circle. We then multiply it by 2 pi. So multiply by 2 pi divided by 360. Nice and simple. Let's put that into practice now. But the first thing I need to do is work out what percentage of the way around the circle each of these numbers should go. I'd like my naught to be at 12 o'clock, this to be at 1 o'clock, 2 o'clock, 3 o'clock, etc. Exactly like a normal clock. So what I'm going to do is first of all find the relative positions. So we can just take the index of these and let's put that onto text and then calculate that by the hour of the collision per grouping. So for morning, I want to count across 1, 2, 3, 4, which is what the index does, all the way up to 12. Then I want it to restart down here because we are into a new group and index all these. So this gives me the number 1 to 12. So far, so good. Now what I'd like to do is divide this by the number of points there are to get the percentage of the way around the circle. So we're going to divide this by 12. Great, so our first point is going to be 8.3% around the circle, the next one 16.6, etc. So that's not quite what I want. I want this point to be at 12 o'clock. I want this to be 0% of the way around the circle. So let's take this and make sure my index starts at 0 rather than 1. There we go, so I'm counting all the way down, 0% around the circle, all the way around to 91.6% of the way around the circle. So that's that first job done. Now we need to multiply this to get the angle. So that angle that I was showing here is the angle of the amount of the way around the circle. So we're going to need to convert this percentage into a degree. So we're going to need to multiply it by 360. But remember, this calculation to convert it to radians divides it by 360. So in essence, we can skip that step and simply multiply by 2 times pi to convert it to radians. So let's do that. 2 times pi multiplied by the index gives us the number of radians around the circle. Great stuff. So while I'm doing that, what I want to do is now calculate the x and y values. So let me move these down here. And I'm going to just move this up here. And for my x value, remember, I want to do the sine of this. And if I copy this and put my y value, make it the cos, and just fix this so that it's computing over the right things, then perfect. We've got the start of our circle. Now, the last thing I want to do is just split out that morning and afternoon. Super. So we've got our circle. This is 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, etc. Exactly as we wanted. So that calculation is calculating the x distance across and the y distance from 0 up or down. And it's giving us exactly what we need. So let's turn those into proper calculations. So I'm going to drag them down here, rename this to x, and rename this one to y. So next step, let's multiply this by the number of strikes. So the sum of the number of strikes multiplied by that. I'm just going to copy that so we can paste it nice and straightforwardly into our y value. Voila. Except it's not looking quite right, is it? Well, in fact, let me just check that calculation because this doesn't look... We've got no negative values here. Oh, we've lost that sine value. One of the autocomplete problems of Tableau is whenever you type that in, you lose that beginning value. So I've put that sine back in now. That should start looking a bit better. There we go. So it looks okay. You can see that the distance away from the radial kind of makes sense. But it's not really doing what I want to. What I want to do is draw a path from the center point out to each of these points as my first step. How do I do that? Well, each of these is only 1 point. I'd need to create the point twice. So let's do that. And to do that, I'm going to duplicate my data. So rather than 1 point per data set, I've got 2. So I'm going to pick this up, drop it just here. Now I am creating an extract. So it's just going to take a few moments to recreate that extract. And we're away. And what this has done is given us a sheet and a table name because we've done that union. And inside this table name, we've got the first copy of the sheet, the data, and the second copy called Wild Strikes 1. So what I'm going to do is just create a group that helps us tell these apart. And I'm going to call this group 1, and I'm going to call this group 2. And let's call this the path variable. Because what I want to do is say, if my path equals 1, then I want my value to be 0. Else if my path equals 2, then I want my value to take this value, which is moving the x position around. Now I'm going to get an error. The reason for that error is because I've got this cannot mix aggregate and non-aggregate comparisons. Because I've got the sum here, I'm summing up my data and aggregating it, which means I can't use a dimension here. So instead I'm going to wrap this in the attribute value. What the attribute does is just gives me the value of that variable if there's only one unique value for that variable. So when I click OK, because we've got at the minute, two different path variables in this data, it can't tell the difference, therefore it's going to break the visualization. Can't tell the difference, it's coming up star when it does that if statement. And star tells me that it can't tell that difference. So instead, what I'm going to do is pick up this path variable and drag it down here onto detail. Now that function is these marks are being broken up by that path variable, which means the function can tell the difference. Now it says, well, if my path variable has got 1 in, then it's going to put it bang in the middle, just here. And if it's got a 2 in, it's going to calculate that old calculation that we did. So we get lots of points in the middle and the other points around the edge. So now, if I want to create a line and just join those together with that path variable, then what I was expecting to happen is that we join from the middle out to that variable. Now what's going on here and why is it not working? Let's just check my path is, so we've got 1 and 2 just here, 1 and 2 just here. What I didn't do is update my y calculation. So let me copy the whole thing actually, because that's going to be really quick to update. So now when I do the same with y, except with a cosine, there we go. And now I can put this number of strikes, say, onto colour. Give us this nice radial clock, and the length of the line tells us how many strikes they've done. Again, I want to create a Coxcombe, kind of a pie chart with the segment size telling me just how big the number of strikes are. So let's fix this. In order to create the next bit of the segment, I've already gone up here for 12 o'clock. I want to go down here to draw the next bit of the segment. So let's do that. How do we do that? Well, we edit the data and add more data to pad out our data set, so I've got access to even more data points. Let's go back to my sheet. Now I've added that union, and we should have a third group, so that I can now edit this and say, well, what do I want to do if I'm on path 3? Well, if I'm on path 3, I want to be on this radial point, because I've already come up here. I now need to move across at the same distance, but along this line just here. Therefore, I don't want to -1 from my index, because I want to be looking at the next point along. If I'm at 12 o'clock, I want it to move to 1 o'clock when it's joining the line together. There we go. Nice and straightforward. Let's do the same thing just here. Number 3, and take off this -1. There we go. So point 1 starts just here. Point 2 goes just here. Point 3 moves along the next radial along and goes to that distance. And we're joining them together in order. Now, if I want to use a line, that's great, but I might want to use a polygon type, because the polygon type will then join that last point back to the original one and fill in the gaps. Looking great. We're kind of there. We've done what we want to do. One thing I would like, though, is this is going between 12 and 1 o'clock. I'd like this centre of this to point at 12 o'clock. Well, how do I do that? Remember that this is pointing straight up, so I've used the index as -1. What happens if I take index minus 0.5 and move it halfway between this point and this point, and move this one back to just here? Let me show you what happens. So if I take off another 0.5 to move it halfway between the 11 and 12 o'clock, and this one, I'm going to add in the minus 0.5. And if I do the same on Y, 1.5 and minus 0.5, we've got exactly what we want. 12 o'clock is now pointing directly up. 1 o'clock is pointing where we need it. 3 o'clock is pointing across. I'm going to change the border here to white, just so they stand out a bit more. Well, this is looking good. This is looking good. But sometimes in my Coxcombe, I like a circle in the middle. We can do that. It's going to be a bit more tricky. So what I'm going to do is just add another variable to my path to get a 4th point. Let's drag that union in. Come back into my main sheet. And now, in my path variable, I can change this to 4. And now in my X, I've got a 4th variable that I can play with. But let's think, as I do that, what we want it to do. Well, this first one no longer wants to sit right in the middle. We want this one to come out to a certain point, just here. Now, how far do we need it to come out? Well, let's say the radius of these is about 1,500. I could do it to about the 500 radius mark to produce a nice size circle for this. So let's do 500 times, and we want it to come along the same route as this one, our first point. So our first point is going to start at the start of our segment, and it's going to come out to about the 500 mark and draw a mark there. Now this one, we'd like to be the length of those number of strikes, but go out as far as 500 plus the number of strikes. Remember, our circle is not starting at 0, it's starting at 500. The same goes for this one. And lastly, we want the point to come out to 500, but only as far as this line segment, the second line segment. And we want to do that if the path equals 4. Now I'm going to copy this and just use it for my Y value. Paste it. That's a cos. That's a cos. That's a cos. And that's a cos. So now we're moving out to here, point 1. Point 2 goes this far. Point 3 goes this far. And point 4 goes this far. All by using those trigonometric functions that we talked about earlier. So the hypotenuse in this case is 500. We've calculated the angle, which gives us minus 123. And then moved it up here. Moved 3rd point, 4th point. I'm going to tidy this up now because I'm happy with it. Turn off the headers. Turn off my grid lines. Turn off the 0 lines. And we've got what looks like a very nice, if if I just turn off the row dividers too, we've got what looks like a very nice Coxcombe chart. I hope that makes lots of sense to you. I hope that I've been able to explain it in a way that you understand. The functions aren't too difficult. They're just the distance you want to move out multiplied by the sine of the angle and the cos of the angle. You just need to remember to convert to radians. Any questions, please do ping me a note on Twitter. It's been fantastic talking to you. Any comments, please let me know. Cheers.